So in this video, we're going to talk about calculating the determinant of a matrix, and I think I will start by just telling you what is this. So determinants come up with n by n matrices or square matrices, so 2 by 2, 3 by 3, 7 by 7, whatever you want. So you have to have an n by n matrix, and every n by n matrix has a real number associated with it called the determinant. So this is a calculation we perform on square matrices, and this only works for square matrices. Now, the notation for this looks like this. So you have the matrix name, which is very often like a letter, so the matrix A here. And to find the determinant of it, I draw these two bars. They look like absolute value bars, but in this context, because context is everything, this means determinant. Okay, so I think the easiest way to show you how to find a determinant is to just do it. So let's start with this first matrix A. And so remember, for a matrix, you have the little square brackets. So this is how I know it's a matrix, because they're brackets. And then to find the determinant, so then I'm just going to draw the little bars like this. Now I'm a visual person, so I think it's really easiest to explain this with a little visual aid here. So to calculate the determinant, you're kind of going down the diagonals. So you've got 2 times 7, and then minus, and then you're going to take these two, -5 times 4. So for this size of square matrix, this is how you calculate the determinant. And so then I just have 14 plus 20. So the determinant in this case is 34. So the determinant, you have to have a square matrix. This is the only way you can do it. And then it's this calculation that we all know and understand based off of what's in the matrix. So in this case, the determinant would be 34. Now I will mention that calculating the determinant is easiest with a 2 by 2 matrix. But it's essential that you know how to do this, okay? So the first thing I want you to do is I want you to take a second and I want you to calculate the determinant of this matrix. Math is not a spectator sport. So the best way for you to do this is for you to pause the video, try it yourself, hit play when you think you've got it. All right, so I'll calculate the determinant. So I'm going to use the proper notation. And then, so I'll just stay visual here. So I'm going to have -5 times 4 minus -3 times 1, and so that's going to be -20 plus 3, so that's -17. Okay? All right, cool. So now let's pivot to a 3 by 3 matrix. Now this gets a little harder. So I'm going to show you how to do this, and then we'll kind of break down some of the terminology associated with this, and then we'll do it again. All right, so with 3 by 3 matrices and with larger matrices, this becomes more of an iterative process. And there's a lot of different ways you can do this. I will tell you just the way that I visually think of this. I don't like, I'll tell you about the terminology, but I think the terminology makes this a little more confusing. I think it's easiest to explain this with a visual explanation. Okay, so here's the deal. I'm going to go across this row, okay? And so I'm just going to take each element in this row. And what happens is when you take this element, so I want to just show you how we cancel things out. I'm starting here. So what I'm going to do is I'm going to ignore this column and this row. And so what I'm left with is this little quadrant, we'll call this a submatrix here. So I want to show you the calculation then. So to find the determinant of this, what I'm going to do is I'm going to take 1 times the determinant of this little submatrix, okay? That's the first part. Okay, now I recommend, if you're taking notes on this, you might want to think about even drawing this matrix 3 times just to be super visual, or use a couple different colors or something, do something to make this nice and visual. Okay, so this is the first part of the calculation. There will be 3 parts of the calculation as we go along each row. So now I'm going to get rid of all that work, and I'm going to go from here to here. So now here will be my element. And so once again, now I'm going to kind of cross out the associated columns and rows. And the little submatrix that's left now are these elements and these elements. So the way that this works now is this is going to be, you always go minus 2 times -2, -3, 3, and -2. So see how those are the 4 elements that are left over? And then, so the pattern goes, you go plus, minus, plus. I know this is a lot I'm throwing at you. Like all the patterns will start to make sense in a little bit. So just for now, just say we subtract this. Okay, so now we've got the little submatrix here. And then we're going to do this one more time. So let me get rid of all this. And for the last time, now we go over here to 3. So I'm going to cross out the associated column and row. And so when you're calculating determinants, the sign in front of these numbers here, it alternates. So this goes plus, this goes minus. So then this is the last one in the pattern. So this will go back to plus 3 times this little matrix that's left over. Okay, so this is how you calculate the determinant of a 3 by 3 matrix. So it's a bit more work, but it's very visual. If you kind of understand like how you're breaking everything down, it becomes very, very visual. Okay, so now what we're gonna do is, let me actually make some space so we can finish this. All right, so here are all the pieces of my calculation. So to find the determinant of A, so I'm gonna have 1 times the determinant of this little submatrix here. So this will be 1 times -2 minus -3 times 4. Okay, so that's the first calculation. Let's just set up all the calculations here. Next, I go to this little part here, right? So this is -2 times -2 times -2 minus -3 times 3, okay? And then we're going to have plus 3, and this will be -2 times 4 minus 3 times 1. So there's all of these little like submatrices. Now I've got everything kind of broken down. So let's see if I can finish this. So this will be 1 times -2 plus 12 minus 2 times 4 plus 9 plus 3, and let's see, this is -8 minus 3. Okay, and I'll clear a little space. And now, let's see, I'll just keep going with my calculation. This is 1 times 10 minus 2 times 13 plus 3 times -11. So let's see, that's 10 minus 26 minus 33. So the determinant of A equals -49. Okay, so I'm glad that we got a negative answer. So, you know, determinants, they can totally be negative. We saw it in the last example. This is fine too. So determinants, it's just a real number. A real number can be positive or negative. And so in this case, this is how we would calculate the determinant. So now that you've seen kind of how we approach calculating this, I want to give a little more color to some of the terminology associated with this. So those little 2 by 2 sub matrices that we had, those are technically called minors. And so the symbol, this M, so this is a sub I sub j. This symbol M sub I sub j represents the minor when row I and column j are eliminated. So we saw how we were kind of doing that, right? So the thing about minors when you're doing this is you can actually calculate determinants however you want. So you can set up your minors kind of however you really want to do it. I'm going to show you more of what I mean by that as we go through the video. I'm just going to mention that for now. So, okay, so first of all, like the minor 1, 1. Okay, so this is row 1 and column 1. So in row 1, column 1, we're talking about this element here. So the minor associated with this element, well, we already calculated this one, right? So if I asked you what is the minor associated with m sub 1, 1, this would be 1, -3, 4, and -2. So that would be that minor. But you can calculate minors whichever way you want. So let's say that I had minor sub 3, 2. So this is standing for row 3, column 2. So here's row 3, column 2. So that is this element here. So I can still find a minor associated with this. So I cancel out this row and this column. And so the minor that is associated in this case is, so I just take these elements, 1, -2, 3, -3. So 1, -2, 3, -3. So it's important for you to know that you can actually find these minors in other ways, because there are easier ways to calculate these 3 by 3 determinants. The first way that I showed you is not the way that you have to do it. There are cases where this is easier, and so knowing how to calculate these different minors is very helpful. Now, the other thing I want to talk about is that number that we multiply the minor against is the cofactor. So, like when we were here, I would have taken 4 times this minor. 4 would have been the cofactor. Now, the thing with cofactors is that you have to know what sign to put in front of the cofactor. And I think the easiest way to explain this is by using this little determinant, or like this pattern here. So this is how you determine your cofactor signs. It always starts positive, negative, positive. So you might remember that I was like, we're going to add this element, subtract this element, add this element. That's because of just how the cofactor signs work. But if I wanted to expand my determinant, say along this row here, which I will show you in a few minutes, then I would have to start with the first cofactor would have to be negative, positive, negative. So I would say just know this is the reference here. This is the really handy way to think about it. And I'll kind of keep referring to this as we go along. Okay, so what I want to do now is I want to show you how to find the determinants again, now that we've added some color to all that discussion. Okay, so I've got this 3 by 3 determinant here. And the first thing I think when I look at this is I want to expand along this row. So you are allowed to expand along any row or column that you wish. So if you see something that has smaller numbers or zeros, that's almost always where you want to expand along. So I would like to expand along this row. And so I'm going to have to keep in mind that my cofactors are going to have these signs associated with them, okay? So let's talk about how that actually works. So I want to expand along this row. So I'm going to start with this element here. And so I'll cancel out this column and this row. Okay, so when I set up the calculation here, using this little cheat sheet, the first cofactor has to have a negative in front of it. So I want to be really clear about this. This will be negative 1 times, oops, I'm sorry, this is my determinant of A. Okay, times 7, 8, 5, and 1. So here's my cofactor times my minor. Okay, and now I'm going to continue on along this row. So I'm going to get rid of all this. Now I'm going to move along to this element. Now here's the beauty of expanding along this row. This is 0 times something, right? So 0 times, so even if I were to cancel out the rest of the column in the row, so according to my little cheat sheet, so for my cofactor, this will become plus, right? So I'm going to put a plus sign, plus 0 times. Now I could say 0 times, and I will just show you what the minor is, 2, 8, 3, and 1. But I don't even have to calculate this determinant now, right? Because it's going to be times 0. So this is what I'm trying to tell you, is that you can make a strategic choice of where to expand along, and then you can make the work a lot easier. Because if I see a 0, that's where I want to expand along, because then it's going to save me a bunch of work. Okay, so let's keep going. So now I have the final element here, this last one. So I expanded along this row of ones. So here's where it's going to do the work to find my minor. Okay, so this cofactor, is it going to be positive or negative? It will be negative because we're expanding along the middle row, so it should be a negative here. So, so this will be minus 1 times 2, 7, 3, and 5. All right, and so now we've got everything that we need to finish the calculation here. So let me make a little space. Okay, and so now for my determinant, this will be 1 times 7 minus 40. So I just went ahead and I just did the calculation. 7 times 1 is 7, 5 times 8 is 40. So the next part is plus 0. I'm not even going to calculate the next determinant because it doesn't matter, right? Because it's going to be multiplied by 0. And then minus 1 times 10 minus 21. And so now this will be negative 33 plus 21, plus 11. So this equals negative 22. All right. And okay, so now let's do one more. And okay, so the thing with determinants, you are allowed to expand along either a row or a column. So you can't go bouncing around the rows or the columns, but you can go across a row or column. So when you look at this determinant here, this is clearly where you want to expand along, right? Because you got those 2 zeros. So I want to issue a challenge now to you to see if you really understand this. You understand kind of how the cofactor signs work. I think you should be able to finish this one totally on your own and then hit play when you're ready. Okay, so I'm going to go ahead and calculate my determinant. So like I said, I want to expand along this column, which is going to be awesome. So I'm going to start here. So I cancel out here and here. So this is going to leave me with 1 times 2, 3, 5, and 2. And I know it's going to be a positive one because we start here positive. So I go positive, negative, positive. And then the beauty is, so now as I continue on along the way, this will be minus 0 plus 0 for the other two parts of this, right? Because I will continue to expand along here to this 0. This would technically be a minus 0, and then I would continue down this way to plus 0. So if you have zeros in your matrix, you really want to expand the determinant along them because now this is just like such an easy problem. So let's see, this becomes 1 times 4 minus 15. So I get that my determinant is just negative 11. Okay, so that brings us to the end of this video. I have another video where we'll talk more about determinants and determinant theorems. So I will catch you guys in that one. Thanks for watching.